AP Cal kids, this is your solution to your FRQ number 5. So we're going to walk through each part of this and I'll give you some idea of how it might have been scored. So we have this, this differential equation, dy dx equals x to the fourth times y minus 2. And we are supposed to, first of all, for A, to sketch a slope field for the given differential equation. So if I need to do that, then I have my point, which is going to be an x and a y. And then I have dy dx, which is defined as the x to the fourth times y minus 2. And I have these 12 points that are listed here. So since my derivative is a product of a power of x and y, let's start with all the points where x is 0. So that would be the point 0, 0, 0, 1, 0, 2, and 0, 3. And in every case, my derivative is going to be 0 to the fourth times what y is, right, minus 2, which is really irrelevant because since I'm multiplying by 0, all these derivatives would be 0. So I have horizontal lines that would go on my slope field at every point where x is 0. So that's one thing to look at. The next thing that we're going to look at would be anything that would make y minus 2 0, which would be when y is 2. So I've got two additional points where y is 2, the point negative 1, 2, and the point 1, 2. So that would be this point here and this point here. And in both of those cases, my derivative is going to be what x is, so negative 1 to the fourth times 2 minus 2, which is 0. So, and that would give me 0 in both cases. So I would get horizontal line segments here and here. So typically the way slope fields are graded, that your points along the y-axis and along the line y equals 2, where you have 0 slopes, will get you 1 point. Okay. So now we've got a few more points to do, and we've got these points where so we've got these points where y is 0. So I have the point negative 1, 0, and 1, 0. So my derivative is going to be negative 1 to the fourth, which of course is 1, times 0 minus 2, which is negative 2. So that slope would be negative 2, and replacing x with 1 instead of negative 1 is still going to give me 1 when I raise that to the fourth. So there I have slopes of negative 2. So my slope is going to be negative 2 here and here. When I come in and I take a couple more points, so I take my points maybe where x is 1 and then y is also 1, so that would be true for negative 1, 1 or 1, 1, then my derivative is going to be either 1 or negative 1 to the fourth times 1 minus 2, which is negative 1. So in both of those cases, my slope is going to be negative 1, which is going to be like this. And then finally, I have the points where y is 3. So that would be where x is either negative 1 or 1 and y is 3. And my slope would be that 1 or negative 1 to the fourth, which of course is 1, times 3 minus 2, which is 1. So these slopes would go upwards here. So your second point is going to have the correct positive slopes and negative slopes with our steeper slopes here along the line where y is 0. So that's going to be our second point. So this is out of 2 points. So that's part A. Let's go on and let's look at part B. So for part B, we are told that we have a slope field for 12 points, but of course there are many more. that derivative would be defined at every point in the xy plane, and we're supposed to describe all points for which the slope will be negative. Well, our slope, dy dx, is defined as x to the fourth times y minus 2. So what we're really looking at is what would make that slope, right, that quantity, less than 0. Well, we know that this will only be, right, that this x to the fourth is always greater than or equal to 0 because we're raising the input to the fourth power. So the only way this derivative will be negative, right, will be if y minus 2 is less than 0, which is when y is less than 2. So to answer my question, right, that answer would be that all points above the line y equals 2 will have negative slopes. Okay. And I'm going to guess that the rubric would give a point for that. So right, describing all points, so any point above the line y equals 2 would have a negative slope. All right, so that's B. Let's go on to C. So C says, find the particular solution, y equals f of x, to the differential equation. So we want to find the solution to our differential equation with the initial condition f of 0 equals 0. So our concept here is going to be separation of variables with an initial condition. So we're going to start with our differential equation, and that is dy dx equals x to the fourth times y minus 2. And my first step is going to be to separate my variables. So I'm going to multiply both sides by dx and then divide both sides by y minus 2. So that gives me 1 over y minus 2 dy equals x to the fourth dx. I want to anti-differentiate. So I'm going to come in here, and my left side doesn't fit an integration formula, so I'm going to use substitution. I'm going to say let's let u equal y minus 2, so du is equal to dy. That gives me a substitution for y minus 2 and for dy. So this becomes the integral of 1 over u times du equals the integral of x to the fourth dx. Right. That is, of course, the ln of the absolute value of u equals 1/5 x to the fifth plus c. Now that we've anti-differentiated, we can come up here and we can use our initial condition, which is the point 0, 0. But this is a number for y. So I've got a choice. I can either take my expression here back into y, or I can change my y of 0 into a value of u. Let's go back into y. So we're going to plug 0, 0 into the ln of the absolute value of u, where u is equal to y minus 2. So that's the absolute value of y minus 2 equals 1/5 x to the fifth plus c. So substituting, we get the ln of the absolute value of 0 minus 2 equals 1/5 times 0 to the fifth plus c. This would be the ln of the absolute value of negative 2, which is 2, equals c. So if c is the ln of 2, then this equation, right, using that, becomes the ln of the absolute value of y minus 2 equals 1/5 x to the fifth plus the ln of 2. Applying my circle rule here, we change this to e to the 1/5 x to the fifth plus the ln of 2 equals the absolute value of y minus 2. That would be that the absolute value of y minus 2, right, rewriting this as a product of powers with the same base, that's e to the 1/5 x to the fifth times e to the ln of 2, which is 2. So I get the absolute value of y minus 2 equals 2 times e to the 1/5 x to the 5th. So resolving the absolute value, I get y minus 2 equals plus or minus 2e to the 1/5 x to the 5th. Adding the 2, I get y equals 2 plus or minus 2e to the 1/5 x to the 5th. Right? But we can come in here again. We have the initial condition of 0, 0. So that means that if y is 0, I would get 0, it has to equal 2 plus or minus 2 times e to the 1/5 times 0 to the 5th. Well, that would be that 0 has to equal 2 plus or minus 2 times e, right? 1/5 of 0 to the 5th is 0, and e to the 0 is 1, so that is 0 has to equal 2 plus or minus 2 times 1, which is 2, and the only way 0 equals 2 plus or minus 2 is if we use the minus and not the plus. So what that tells us then is that therefore our equation is y equals 2 minus 2e to the 1/5 x to the 5th. So rewriting that where we can read that a little better, right? Our equation becomes y equals 2 minus 2 times e to the 1/5 x to the 5th. And we've solved our differential equation. Okay. So as far as the points for this, rubrics vary a little bit, but basically if there is no separation of variables, then there are no points. But in the separation of variables, there might be 1 or 2 points assigned for that. So I'm going to give 1 point for getting 1 over y minus 2 dy equals x to the 4th dx. And then for the integration, there might be 1 or 2 points, but I'm going to give this 2 points. So 2 points for anti-differentiating the left side, or 1 point for anti-differentiating the left side, 1 point for anti-differentiating the right side, and then typically you get 1 point for adding the c. You get 1 point typically for substituting your initial condition and finding the correct value of c. So those kind of go together. So we have 1, 2, 3, 4, 5 points, and then 1 point for the final answer. So that gives us 6 points for this. So that's the working of this. Hopefully you did well in that. You can let me know tomorrow how you scored that.